Okay, so transformations or moving graphs around. So we want to think about if we move a graph around, how does the function change, the formula for the function? And if we change the formula for the function, how does the graph change? So we will look at moving up and down, left and right, stretching, contracting, up and down and left and right, reflections, and then putting them all together. We have a couple of standard graphs, and then we have problems of given the formula, what's the graph look like? Given the graph, what's the formula look like? So here's a graph. This is a function, y equals f of x, right? We know it's a function because it passes the vertical line test. So it's a function. Domain of this function, well, it goes from -2 here to 2 on the x-axis. So -2, 2. And the range goes from -1 on the y-axis up to 3. So -1 to 3. Right? We don't really need that, but let's at least notice that as we're going by. So here's a function. So this is y equals f of x. And the question is, if we write f of x plus 3, what does the graph of that look like? So we're thinking we're going to take an x value, we put it into the function to find its y value, and then we add 3 to that to figure out what the new y value is. So if we look at A has x coordinate -2 and its y coordinate is 0. B has x coordinate 1 and y coordinate 3. And C has x coordinate 2 and y coordinate -1. So we take x, we find f of x, and then we add 3 to that y value. So that gives me 3, 6, and 3 plus -1 is 2. So we can make a table here. What's f of x plus 3? Well, my 3x values that I have were -2, 1, and 2. And the outputs that I get are here. So I have a function like that. And if I graph that function, x is -2, y is 3, that's here. X is 1, y is 6, that's up here. And x is 2, y is 2, that's up there. So there's our function. And what we've got, if we call this point A prime, this point B prime, and this point C prime, is that the points have just moved up. Right? So that's the effect of adding a 3 outside of the function, is that the graph moves up 3 units. And subtracting a 5 would be down 5. Okay. F of x minus 3. And here the 3 is inside the parentheses. So here's the parentheses for f of x, and we want to know what's f of x minus 3. So we know that a is -2, and if we plug in -2 into the function, we get out 0. B has got an x coordinate of 1, and if we plug that into the function, we get 3, and the y coordinate for C is -1. But here, we want to start with an x value, and then we get an x minus 3 value by subtracting from it, and then that's what we put into the function to get f of x minus 3. So if x minus 3 is 2, and you put that in the function, you get f of -2, which is 0, which we can tell from the graph. But what's x? If x minus 3 is -2, well, x must have been 1, right? Because 1 minus 3 is -2, and then you plug that in the function to get that. So if we're trying to build a table, x, y, where our outputs are 0, 3, and -1, what do the inputs have to be? Well, this one would have to be 1. If we want 1 to go to, it's an arrow, f of 1 equals 3. If x minus 3 is 1, what was x? X had to have been 4. Likewise, if x minus 3 is 2, x had to have been 5. So actually, we end up with the points for f of x minus 3 as being 1, 0, call that A prime, and then 4, 3, call that B prime, and then 5 minus 1, that's down here, we'll call that C prime. And our graph looks like that. So all these 3 points were moved right 3 units. So subtracting 3 moves the graph right units because 3 units, because if we take x equals 5, we subtract 3 from that, get x minus 3 equals 2, and then we plug in c to find the y value. So in addition, this moves the graph left 2 units. Okay. So stretching, contracting, this is involving multiplication. So here's the graph of y equals f of x. And we want, what does 2 times f of x look like? What does the 2 do to it? So here we're taking x, and we're putting it into the function to get a y value. And then we're taking that y value and we're multiplying it by 2. So if we take these 3 x values and we put them into the function, we get our usual 0, 3, and minus 1, like we get from the graph. And then we're going to multiply these y values by 2, 0, 6, and minus 2. So we're dealing with 2 times f of x. The x values we have are this, and our y values now are 0, 6, and minus 2. So a prime keeps the same y value. B prime is now 1, 6. And C prime is 2 minus 2. So the graph is actually stretched out by a factor of 2, which means this distance here is 3. And so if you double that, you get 6. This distance here is 1. If you double that, you get, well, it's minus 1 because it's down, you get minus 2. So how far the point moves depends on how far it is from the x-axis. The further from the x-axis, if we're 3 units up, the further up you go. And if you're actually sitting on the x-axis, you don't go anywhere because 0 times 2 is just 0. 1/2 f of x would contract, that's an x, to the x-axis. 2 stretches away from x-axis by a factor of 2. Right? So 1/2 would mean this would stay where it is, b would come here, and c would go to there. And so if we multiply by 1/2, everything would come closer into the x-axis. So here's our same graph. What is f of 3x? And now the 3 is inside the parentheses. And so what we're doing is we're going to take x, and then we multiply by 3, and then we use that to get our output. So we know that if 3x is minus 2, and we plug that into the function, we get out 0. But again, if 3x is minus 2, what does x have to be? 3x equals minus 2, that means x is minus 2/3. Okay? So if I plug in x is minus 2/3, then 3 times x is minus 2, and then f of minus 2 is 0. Likewise, if I take x to be 1/3, then 3 times 1/3 is 1, and f of 1, as we see from our graph, we plug in x equals 1, we get y equals 3. And if we take 2/3 and multiply that by 3, we get 2, and when we plug in 2, we get minus 1. So our table now for y equals f of 3x has inputs minus 2/3, 1/3, and 2/3, and outputs 0, 3, and minus 1. So minus 2/3 is about here. There's my a prime. 1/3 is about here, and we go up to a height 3. So there's my B prime. And 2/3 is about here on the x-axis, and we go down to -1 to get C prime. So having a 3 there means contract towards the y-axis by 1/3, not by 3. And so here we would stretch away from y-axis by a factor of 4 by the same kind of reasoning, right? If 1/4 x equals -2, we set up the same kind of table. X goes to 1/4 x goes to y equals f of 1/4 x. This is the same kind of things we did up here. If this is -2, then putting -2 in the function gives me 0. But if 1/4 x is -2, then x must have been -8. And so then we plot the point -8, 0. Okay, what do reflections do? So multiplying by a minus sign here. Well, again, if we plug in these x values into the function, we get 0, 3, and -1. And now we're multiplying the y value, f of x, by -1. -1 times 0 is 0. -3 times 3 times -1 is -3. -1 times -1 is 1. So the points we'll get is 0, -2, and then x equals 1, y equals -3, that's down here, and then x equals 2, y equals 1, that's up there. So a prime is the same as a, because the y value is 0, and you multiply that by -1, you get 0. B becomes B prime, just flipped over the x-axis. C becomes C prime, flipped over the x-axis. So the minus sign it flips the graph over the x-axis. So what about multiplying inside? Well, it's the same kind of thing that we saw every time we've done something inside. We have to think about this in a couple of steps, right? We take an x value, we multiply by -1 to get -x, and then we take that number and we put it into the function to get our y. So if our -x values are -2, 1, and 2, well, if I plug -2 into the function, I get 0, right? Because that's point A, 3, and -1, B and C. But if -x is -2, what was x? Well, x would have to be 2, and -1, and then -2. So if we take 2, multiply it to get -2, and then put that in the function, we get 0, -1, multiply by -1, plug it into the function, we get 1, and then 3. And then finally, if we take x equals to -2, multiply by -1, that gives me 2, and then I plug that into the function, and that gives me -1. So what's the effect there? Well, -2 becomes 2, 0. So there's my A prime. B becomes -1, 3. And that's over here. B prime. And C becomes -3, -1. No, not -3, -2. So B is still up here. This is B prime. And then C prime is down here. And so we've reflected over the y-axis. So multiplying by -1 inside the function, so that's inside these parentheses, flips the graph over the y-axis. Okay. So here's a graph of a function. It's got 4 points, A, B, C, D, and is connected by lines. What's the graph of y equals -1/2 f of x minus 2 plus 3? Okay, so we need to break this down a little bit. We need a little bit of an order of operations. How do we actually think about which ones we do first? This is very similar to what you may have seen as PEMDAS or BODMAS. Parentheses first. So parens, that means parentheses, because I don't want to write the whole thing out. Multiplication and division first, then addition and subtraction. And then you go outside the parentheses, and you do multiplication and division first, then addition and subtraction. So inside the parentheses, we have an x minus 2, and that means write 2 units. 1/2, that's the only thing that's going inside. We don't have multiplication division. But outside, we have a multiplication by 1/2. So times 1/2 outside. No, that's supposed to be a dot for multiplication. So times 1/2 outside. And that means we're shrinking it towards, contract, towards x-axis by 1/2. And then we have a minus sign outside. So times -1 means flips, oops, let me undo that, times -1 outside, that means flip over x-axis, and then finally we have a +3, and that's not inside the parentheses, so it's outside, and then +3 outside, moves it up 3 units. So this is the order in which we need to do things. So if we start with A, is at -2, 0. So it goes right 2 units to there. And then we multiply its y value by 1/2, and that gives me 0 again. And then we multiply it by -1. We flip it over the x-axis. Nothing happens because it's on the x-axis. And then we go +3. And so that takes it up to here. There's A prime. It goes up 3 units. And we can be a little more detailed about that because we start with A starts at -2, 0. So right 2 units would move it to 0, 0. And it changes the x coordinate. Times 1/2 changes the y coordinate. By multiplying by 1/2, but 1/2 times 0 is 0. Times -1 changes the y coordinate again by multiplying the y coordinate by -1, but that's 0. And then the +3 outside will take us to 0, 3. So what about B? B, we move it 2 units right. So 1 unit, 2 unit, that moves it to here. And then we cut the y value in half because that's outside. And so that takes us down to here. And then we flip it over the x-axis. That changes the y value to -1. And then we move it up 3 units, 1, 2, 3. And so that actually just brings us back to this point as b prime. And again, we can trace that through our steps. We started with b being -1, 2, right? 2 units adds 2 to the x coordinate, times 1/2 outside, cuts the y coordinate. Oops, it's supposed to be 1. Cuts the y coordinate in half, multiplying by -1, changes the sign of the y coordinate, adding 3 to the y coordinate moves it back up to 1, 2. So there's b prime. So C, 2 units right, cut it in half, its y value, so that moves it up to here, because the y value is -2, half of that is -1. So towards the x-axis, the -1 flips that over the x-axis to here, and then we add 3, 1, 2, 3, and we end up there. And our point D goes 2 units right. Its y value is 4. We cut that in half to get 2. We flip that over the x-axis to get -2, and then we go back up 3 units, and that gives me that. So there's D prime. Here's A, B prime, C prime, D prime. And all the other points, they're just lines, so they just get dragged along with those points. And so there's the graph of -1/2 f of x minus 2 plus 3, right? It's this thing here. So we can figure out where these points go, A, B, C, and D, and then the lines in between them, just, you connect the dots. Okay, so we have a couple of standard graphs. This is the absolute value function. It's actually a piecewise function. Right, and so the absolute value of a number, if it's positive, is just whatever the number is. If a number is negative, like -10, its absolute value is the negative of that. So minus 10 is +10. So that's this is a piecewise function. Domain, a lot of different ways to write this. You could write it as all reals, all x, minus infinity less than x less than infinity, or in interval notation like that. Range, however, is either y greater than or equal to 0, because bottom point is at 0, or 0, infinity. And it's got 3 special points, which we'll call A, B, and C. A is -1, 1. B is the point 0, 0, and C is the point 1, 1. And if you can figure out where those 3 points go, then the rest is just sort of filling in the lines. This is the graph of the parabola. It looks a lot like absolute value, except it's kind of rounded at the bottom. Domain, I'll just write all the domains and ranges in interval notation. There's a number of different ways to do that. And if you want to write them with inequalities or anything, that's fine too. Range is 0 to infinity. And again, 3 special points. A is -1, 1. B is the point 0, 0. C is the point 1. Right? So -1, 1 is here, 0, 0 is here. And again, when we're thinking about moving points around, those are 3 good points to keep in mind. And then finally, this is the square root function. Y equals square root of x. Domain, x greater than 0 or 0, infinity. Range, y greater than or equal to 0 or 0, infinity, right? Because the graph starts here, there's no square roots of negative numbers, and the outputs, we're taking the positive square root here. So there's really only 2 special points here. Call this one A and this one B. So A is here and B is here. You could have a third one, which is 4, 2, but I generally don't use that one. Okay, so here's a formula, and we want to know what's the graph of that, right? So it's a nice function. What does the graph look like? So we're starting with an x squared. Is our base graph with its three special points, which I called A, B, and C. And we want to know what's the graph of this thing. So what do we have here? We start inside the parentheses. We're going right 2 units because of the -2. Outside, we have a times -1, right? The minus sign. That means flip over x-axis. And then we have a +4, which is move up 4 units. So if A is -1, 1, what happens to that? Goes right 2 units, so that means adding 2 to the coordinate, x coordinate. -1 means multiplying the y value by -1, and then we move it up 3 units, means adding 3 to that, adding 4 to that. So right 2, that changes our x coordinate, times -1. Outside means we multiply the y coordinate by -1. And then +4 outside means we add the -1 plus 4 to get 3. So A moves to there. What about B? Well, B is 0, 0. And if we move that right 2 units, right, 0, 0 ends up there. Flip it over the x-axis. It's on the x-axis, so nothing happens. And then we add 4. 1, 2, 3, so there. That's where B prime goes. And what about C? C is 1, 1. Where does that go? Well, if we start at 1, 1, move it right 2 units would take us to 1, 2, 3, 1. Flip it over the x-axis would take us down to -1, and then we add 4 to that, 1, 2, 3, 4, and that takes us up to here. So C prime ends up being 1, 2, 3, comma 3. And then we can just draw in the parabola, because once we know where those 3 points go, the rest of the parabola just sort of gets dragged along with it. What about this? Well, our base graph here is y equals absolute value of x. And it looks like that. So inside, that means left 5 units. Outside, times -1/2, that means flip over x-axis, that's the minus part, and contract towards the x-axis. And so again, we look at our 3 points. A, which is -1, 1. B, which is 0, 0. B, and C, which is 1, 1. And where do those 3 points go? Well, -1, 1. Left 5, so that means subtracting 5 from the x value, that gives you -6, 1. Don't know why I underlined that. And then you multiply the y value by -1/2, so that gives you -6, -1/2. 0, 0, left 5 units gives you -5, and that changes the x but not the y. And then you multiply the y value by -1/2 because that's outside, so that gives you -5, 0. And then where does 1, 1 go? Left 5 units will take you to -4, 1, and then you multiply your y value by -1/2. That gives you -4, -1/2. Good. So what's the graph look like? Oop, I didn't leave myself much space. So we have -6, -5, and -4 is our x values. And at -6, we're at -1/2, and -5, we're at 0, and at -4, we're at -1/2. So a graph looks like that. It's been moved left 5 units, flipped over the x-axis, and flattened out a little bit, contracted back up towards the x-axis. What about 3 times the square root of -x? Well, our base graph here is y equals square root of x, because it's a square root function. And that looks like this. A equals 0, 0. B equals 1, 1. And what do we have here? Minus inside means flip over y-axis. Three multiplication outside is a stretch away from x-axis. So if this is y equals square root of x, another way to approach this is to say, well, oh, that's a terrible drawing. Let me undo this. The first step is to flip it over the x-axis, over the y-axis. That's the minus x inside. And that leaves a at 0, 0. And b prime now, the point b becomes the point 1 minus 1. And then stretching it by a factor of 3, what does that do? Well, that's going to leave this point alone. So we'll have a double prime equals 0, 0. And because if we multiply 0 times 3, we get 0. And then b double prime would be 1. This should be minus 1 plus 3. And this is minus 1, 3. This has now been stretched up 3 units. So we flipped it, and then we stretched it, and you can sort of do a 2-step diagram like that. So now the other question is given a graph of a function, what's the formula of this function? Right, and so this is y equals absolute value of x, because it's got a nice point to it, and it's been moved and shifted and whatever. So absolute value of x, the bottom of the v is what I've been calling b equals 0, 0. So here the bottom of the v, or the top of the v in this case, is at the point -4, -3. So what does that tell me? That tells me I've moved this graph 4 units left and down 3 units. Moved. Wow, some bad spelling going on today. Moved left 4, down 3. And so these 2 points are -1, 1. That's what I've been calling A. And this point is C, which is 1, 1. So if this was all that was done, the point A should go left 3, which would get you -5. Left 4 would get you -5. And then down 3 would give you -2, but I have to be a little bit careful. The other thing we can see is this has been flipped. So the order of doing things then is we're going to go left 4 units, flip, and then down 3. And that would get this in the correct point. Now, minus 1, 1, if we did that, that would take you from minus 1, 1. If we go left 4, would take you to minus 5, 1. Flipping it would take you to minus 5, minus 1. And then going down 3 units would take you to minus 5, comma, minus 4. But that would be here. And we didn't actually, that's not actually the point on the graph. So something else must have happened. And what happened is that if you look at A and B and the relationship between them, A is 1 unit to the left and 1 unit up, right? Same thing with C, 1 unit to the right and 1 unit up. Here, if we go 1 unit to the left, instead of going down 1 unit, so we have to go down 2 units to get to the graph. So we need to throw something extra in here. We need to make this distance twice as long. And so that makes it actually 2. So what we're actually going to need is y equals absolute value. Left 4 means an x plus 4 inside. A flipping means a minus sign outside. Stretch by 2 means multiplication by 2. And then down 3 gives me a minus 3. And that's what the formula is. But you have to be a little bit careful about how to find these kinds of scaling constants, because by looking at the points and where they go and how long the y coordinate is relative to the vertex there. So here's a function. What's the shape of that? That's y equals square root of x. We know what y equals square root of x looks like. It looks like that with these two special points. And so what we want to end up with is a prime equaling minus 2, 0. I'm having issues. 0 minus 2. And b prime, which is 1 unit to the left, is going to end up being minus 1, 1. So what's happened here? Well, we flipped it over the x-axis, right? That's how we got a minus sign here over the y-axis. We've moved a down 2 units. Right? And if that was all that happened, our graph would look like that. Well, not quite like that. It would go through this point. So let me see if I can redraw that better. Down like this, and out like that. Right? And this would be where B would end up. So, but B didn't end up there. B ended up here. So what happened? Well, 1 unit, 1 unit, 1 unit, 1 unit, but we don't actually want a distance of 1 unit here. We want a distance of 3 units. So to get a distance of 3 units, we're going to have to take the y value of b and multiply by 3 to stretch the function away from the x-axis. And so stretch by 3 away from x-axis. So what's our formula if we put everything together? Square root is our basic function. Flip over the y-axis means we multiply by x first, x by minus 1 first. The stretch by 3 means a multiplication by 3 outside, and then moving down 2 units. And if you want to track that, you can go on GeoGebra, some kind of graphing thing to see how that works. So, highlights. These are all outside. And they affect the y coordinates. Right? So adding plus or minus k moves it up or down. That changes the y coordinate. Multiplying by k outside stretches it vertically. And multiplying by -1, changes the sign on all the y coordinates, so it flips it over the x-axis. Inside affects x coordinates, right? This moves it left to right. That means changing the x coordinate, adding or subtracting the x coordinate. This contracts it horizontally to or away from the y-axis. That's again affecting the x coordinates. And this is changing the sign on all the x coordinates, which flips you over the y-axis.